So you, like me, have probably seen nappies floating about, 10 meters down, 20 meters down. You're just like, what's this? What creature is this? And then you just come closer to it. You notice it's actually just a nappy, and there's tons of those guys. They're everywhere, aren't they, So yeah, they take absolutely ages. Where are they? There they are, 450 years, disposable nappies. They're your cartons, about 3 months. They're your cans, about 200 years. Glass bottles are undetermined. That's 100% ceramic, of course. You might have some metal. Pigments integrated to color your silicon oxide there, but, primarily it's ceramic. But then you got like, plastic beverage holders, 400 years and so forth, Takes a long time. You've probably seen a lot of these pictures of, how these things like fishing lines and so forth affect nature and the wildlife. And it is damaging. It is generally bad. But, what can you do about it? That's the question, Well, you can do this kind of stuff if you really want to. I don't believe in it personally. Do you believe in this? This is like, it's basically the use of microorganisms to degrade and destroy and potentially in some cases metabolize the plastics completely. So you have like Rhodococcus species, Pseudomonas species. They can biodeteriorate different plastics, and they, like polyethylenes, polystyrenes, polyurethanes. They will just like basically secrete enzymes which will degrade these things down into base elements and so forth. Then you can have like assimilation, which is a different method. Again, the microorganisms, what they'll do is they'll basically eat the plastic and they will assimilate the plastic into their cells, and then their cytoplasm deals with this. But again, the end result is you have zero plastic, and mineralization. Biofragmentation is more mechanical actually, but mineralization is, completely degraded down, and then you metabolize the compounds, right? And there's one actually recent nice example. It's called Ideonella sakaiensis. It was a group in Japan that discovered this bacterium. And this bacterium basically breaks PET down into terephthalic acids and ethylene glycols, which it then uses to metabolize and generate energy. But I don't believe in any of that. What about you guys? Do you believe in that stuff? Do you think that's a good idea? I actually dislike the idea very much. For myself, I just, like I say, I challenge you to go to the shop, see how much plastic you guys use. And actually, you guys, I also. We all use plastics, right? Isn't it? I mean, it's one of these indispensable materials. And crude oil has a finite lifetime, does it not? It's meant to run out in what, 100 and something years, if I remember correctly. Yeah. But I would argue, don't we need those plastics? Because we use them so much. And they're so important in biomedical fields, in aerospace, in automotives, in packaging, dare I say. I know packaging sounds weird, but it does enable the mangoes to come here, and I like mangoes, So, you see my point is that I don't think getting rid of them is a good idea at all. Yeah. Yes. Right. Yeah. I completely agree with you. Yeah, you're jumping ahead 3 slides now. I don't know if you're a mind reader or something, but basically I completely agree with you. If it's in combination, and I'll get to that in a minute, yeah, as to how it can be used in combination with recycling, which I think is the better alternative. You can't recycle polymer composites generally. You can, theoretically, but, there's tons of energy, tons of chemicals and so forth involved. I once spoke to one of the head guys in Hexcel. Do you know Hexcel? It's like the biggest composites company in the UK. And he was just like, yeah, if you have a plane wing made of composite, you should burn it, because there's absolutely no value or chance in, recycling that thing, because it's so difficult to recycle composites. But they do have, fairly decent lifetimes. So in that sense, it's still good to use them, and they do have other benefits. However, when you look at how we recycle things, you know, okay, batteries, yeah, we recycle batteries pretty well. And that's because we have to, and, you know, there may even be fines involved. But when it comes to plastics, we're not very good at recycling that. And I don't think we have very good schemes in place. They are improving, of course, but, you know, when you're looking at 28% PET recycling, you know, it's not necessarily the way to go, you know. And now I'm going to come to what you were saying. This is one method that I do believe in, is in the dollar, or since I'm in the UK, I say in the pound. Yeah. Well, this is a project that I undertook earlier this year in Indonesia, and basically the idea was Indonesia has the second highest level of oceanic plastic pollution in the world, right? So there's absolutely tons and tons of plastic in the oceans there, but that means there's a lot of money there as well. So the oceans of Indonesia are rich with money, plastic money, right? So the big driver for people around the world is money. This is a fact of life. And what I thought would work, and it is working actually, is to create a circular economy in a local village at the coast. And we just did this pilot trial where we basically machine hacked, or reverse engineered, I should say, shredding and extrusion machines for PET. And basically the idea was we hacked these machines, gave them to the villagers, created this startup company, and then they would collect the PET, shred it, extrude it into this stuff and sell it to plastic banks, which would then, you know, be engaged in product development. So you have this continuous circularity of economy and continuous removal of plastic from the ocean. That's one method I do believe in, because it involves money, and money is the driver at the end of the day. Going back to what you said, every time you reprocess plastics, do you know what happens? Because PET isn't. Yep. You have not energy loss.
It can't be recycled through some form.
That's right, exactly. It's like you degrade the molecular weight of the polymer each time you recycle it, each time you shred it, extrude it, and so forth. So after 10 times, your molecular weight is so low that there's no point doing that anymore. And at that stage, I would say the microorganismal degradation is probably a good way to go. But in the early stages, definitely not.